I welcome you all for this lecture series in the course Mechanics of Solids. Today, our topic is to be a stress, which is a continuous parts of last two lecture series where we have seen rigid bodies and deformable bodies and about stress and strain and in simple bars. So coming to the point, we have stresses even due to temperatures. That is what this today's topic is all about. And understanding the thermal stresses, that is causes, effect, and engineering impact, will tell every mechanical engineer that he has to undergo particular design or any component manufacture using this particular basic concepts of thermal stresses. Considering these thermal stresses will often ensure safety of the design as well as to the safety to the end user. Let us see what are thermal stresses, and coming to the point, results from temperature changes in materials. So any material that is being taken for design or fabrication or application in engineering field will tend to change its shape or size or behavior with respect to temperature. So temperature is inevitable since we are all the materials, engineering materials are exposed to high temperatures either internally or externally. For example, internally, when you take any railway engines, these engines will have to produce lot of horsepower to run the railway compartments. So these railway engines are given thermal power using fossil fuels. This temperature rise will also will uh, affect the property of the material. The external temperature is due to environment, that is sun or any other higher temperature body next to the particular component. So there is always a stress that is called a mechanical stress. Expansion and contraction occurs when materials are physically constrained. So whenever we constrain any body, this expansion or contraction will happen, and the potential failure can lead to deformation, cracking, or structural failure. That is a total failure of the system due to thermal stress. So coming to the thermal expansion, the root cause is material expand when heated and contract when cooled. Expansion is proportional to temperature change. That is, change in length is equated into length into coefficient of thermal expansion as well as change in temperature. There is an initial temperature before the process starts, and there is a final temperature for the process to end. So a steel pipe 15.4 meter long expands approximately 7.2 centimeter when the heated from 19 degree to 410 degree. So this is the change in temperature, and the expansion goes approximately to 7.2 centimeter. So this is how it affects due to thermal expansion. So this alpha value, that is coefficient of thermal expansion, is always different for different materials. And thermal stress formula and interpretation, that is E is Young's modulus. How we are going to calculate thermal stress? The thermal stress is equated to Young's modulus into coefficient of thermal expansion, and which is multiplied by change in temperature. So stress can be tensile or compressive depending on the temperature change and constraints. So temperature gradients and thermal shock. So rapid change, quick heating or cooling causes uneven temperature distribution. So anything which is gradually heated will produce gradual stresses. When it is quick heated, the causes or the affection between the materials is more. And the internal stresses, that is surface expands or contracts faster than interior. And thermal shock can lead to cracking, especially in the brittle materials like ceramics. So real world examples, we have three beautiful examples. That is railway tracks, buckles without expansion joints on hot days. So normally when we travel in train, we hear a small noise from the wheels and the rails, continuous noise. That is because there is a gap between the rails. So this gap is left intentionally to allow the material to expand whenever there is a change in temperature. So this change in temperature will lead to increase in length so that there is a gap, so it is accommodated. Power lines sag in summer, snap in winter if it is not properly managed like this. We all have seen that. And dental fillings, different expansion rate can cause discomfort in dental fillings. So everywhere from our body to the engineering field, the changes or the thermal stress affects more. So these are all the engineering solutions and applications: expansion joints, bimetallic strips, material selection, and finite element analysis to identify where the thermal stress distribution is more. And let us summarize this topic. Thermal stresses in solids. We have seen what is thermal stresses and what is the root cause, formula for that, and temperature gradient, consequences, and solutions to engineering. And we have seen applications. And this particular thermal stress we'll explore more through problems. I hope you all understood what is thermal stress. Thank you.